In this tutorial, I am going to show you how to request an image with MicroObservatory. First, access the main page of the MicroObservatory website by going to www.microobservatory.org. Again, that URL is www.microobservatory.org. On this page, you'll see a set of 4 MicroObservatory access portals. We want the one that says Observing with NASA, which is the first option. This will take you to the Observing with NASA page. Here you'll find a series of tabs along the top. To request an image, you want to click on the first option again, which says Control Telescope. This is called the Select a Target page, and here you actually choose what object in the sky the telescope will take a picture of. So here you'll see that you have roughly 40 target objects to choose from. And whichever object you choose, one of the MicroObservatory telescopes will take a picture of that object sometime later that same night. However, since the Earth is constantly moving around the Sun, some of these objects in the night sky will shift in and out of being visible during the night. The telescopes can't take much of a picture if the objects don't show up in the night sky, which is why certain objects are sometimes grayed out on this page. Right now, it looks like that includes Jupiter and the moons, Mars and an asteroid, and several galaxies and such. But that still leaves at least 30 more to choose from, so I'll choose the Lagoon Nebula. If you want to learn more about a particular object, you can click on the image to read about your target first, but otherwise click the Observe button to start your request. Now that I've chosen my target object, I have to make 3 decisions about how the telescope will take my image. The first decision is what field of view you want. Field of view refers to how large a piece of the sky you want included in your image. Do you want to take a zoomed-in view of your object? Or perhaps you want a wider angle so that you can observe a much larger area of the sky? You'll see multiple options come up for some of the other targets, but for the Lagoon Nebula, we only get one option, normal view. If you were to hold your hand out at arm's length into the sky, normal view would capture a portion of the sky that is about as large as your pinky fingernail. And since normal view is the only option here, I'll choose that. The second decision is what exposure time you want. This determines how long the camera shutter stays open to allow light to hit the telescope's detector. You see, a telescope image is determined by how much light the detector receives from your target object. And if the light detector is exposed to an object for a longer period of time, it will pick up more light from that object. Our detectors already receive a good amount of light from the objects that are closest to Earth, so the detector doesn't need to be exposed to these objects for quite so long. Take the moon, for example. MicroObservatory recommends you use a very short exposure time setting, just 1/10 of a second. For distant objects like galaxies and nebulae, the detector will receive far less observable light, so the telescope detector needs to be exposed to the light from these objects for much longer. Take the Lagoon Nebula. MicroObservatory recommends an exposure time of 60 seconds, which is 600 times longer than the exposure time for the moon. But don't worry if you choose an exposure time that is shorter or longer than our recommendation. MicroObservatory will give you guidance on whether your image will be under or overexposed. Overexposed means the telescope camera was exposed to the light from the object for too long. As a result, the brighter features of your target will show up as white patches in your image, which means a loss of detail in the bright areas of your image. Underexposed means the telescope camera wasn't exposed to the light from the object for long enough. In this case, you will lose detail in the dim areas of your image. The last decision is what light filters you want to use. Within each MicroObservatory telescope is a filter wheel of colored glass, and each glass filter will only let light of that color through to the detector. Whichever filter you request to use will spin into place when the telescope captures your image. Some targets will only have one filter option, in which case just choose that and go with it. But for the Lagoon Nebula, we have the option to choose just red, just green, just blue, or all 3. If we select all 3, we will later have the option to combine the 3 filtered images into one true color RGB image, which will give a detailed picture of the natural color of the object. I'm going to select this option. If you don't yet know how to combine red, green, blue filtered images, you can learn how to do it with the tutorial How to Create an RGB Image. Finally, we have the submission page. Fill in your email address and make sure it's accurate, because MicroObservatory will send your images to your email after they've been taken. Select your age, gender, and state, and how much astronomy experience you have over here. Let us know if you're willing to be contacted in the future or not, and then click Submit. The next day, check your email. An email containing your images should come from MicroObservatory support at cfa.harvard.edu. If you don't see an email, check your junk or spam folder. In some cases, it might take MicroObservatory a couple of days to get certain images back to you, but the majority of images will be taken and sent to you the very next day. And once you've received your image back, be sure to watch the tutorial How to Process a FITS Image to learn how to begin the image processing process.